So in the topic of momentum, children, let me start from the definition of momentum. And momentum, that word, if you find children, can you see the screen? Still?
Yes, sir.
Yeah, thank you. So momentum is basically is given by the product of mass and velocity. First, children, you try to remember this mathematical equation. Momentum is written by a letter P, by letter P. So P, you can take small p, capital P. P is equal to product of mass times velocity. First thing you have to remember about the momentum. It is the product of mass and velocity. Remember this P here, children, that in physics there are many common letters. There, this P is for momentum. It's not power. It's not what we have learned any other quantity related to P. It's not density. Sometimes students they write P for the density. Actually, that is the italic letter rho. So here this P is momentum. It's this P is not pressure. This P is not pressure. This P is momentum, which is equal to the product of mass and velocity. So the momentum is a term which is related to the mass of the object, here this factor. Second term, that it is related with the velocity of the object. So momentum of the object will change. Momentum of the object change if there is a change in mass of the object, and if there is a velocity, there is a change in the velocity of the object. For example, in this case, if I increase the mass and if I increase the velocity, then what's happening with the momentum? It means the momentum is going to be changed. So for example, if I take this truck is there, this lorry is there. Suppose this mass is m and it is moving with the velocity v. But now in the second situation, if I double the mass by putting some more weight, some object on the truck, and in the second situation, suppose mass gets doubled, and suppose the velocity, I have changed the velocity also get doubled. Suppose v is now 2v. What is the momentum in the second case? How the momentum will change? Now you can see here the momentum will be mass get doubled, velocity get doubled. So it means the momentum will be 4 times of p1. Is this clear, children, that the momentum will be 4 times of the p1? So this is the way that you will find some question in exams, that how momentum can be increased, how momentum can be decreased by changing the velocities, by changing the mass of the object. Let me proceed further. And here, one example is there, a simple example. Suppose, children, we have a model car. We have a model car whose mass is 2 kilograms, and that car is moving with a speed or velocity of 3 meters per second. What is momentum? Children, what is momentum? So the momentum will be product of mass and velocity. You need to put value 2 and 3, that is equal to 6 kilogram meter per second. Now, children, one thing here, I want to tell you that momentum, that the topic we are talking about, it's a vector quantity. It's a vector. It's a vector quantity. So if it is a vector quantity, vector quantities are always linked with the directions. Their directions are important, as velocity is a vector quantity, force is a vector quantity. Similarly, momentum is a vector quantity. And if momentum is a vector quantity, the direction is very important. So you have to remember, children, if the object is moving to the right hand side motion, to the positive x-axis, okay, then consider that motion is positive, means momentum is positive. You have to take a positive sign, whatever the values are given for the momentum. If the object is moving to the left hand side means toward the negative x-axis, if I consider, so then you have to take the momentum will be negative. Why we are talking about this positive and negative, children? Because momentum is a vector quantity. So vectors are always, it can be positive, it can be negative. So, and other thing about the momentum, its unit. What is its unit? Children, that generally students make a mistake in writing unit of momentum. Momentum is linked with the mass, it is linked with the velocity, and you know the unit of mass is kilogram, is kilogram, and unit of velocity is meter per second. So the combined value, kilogram meter divided by second, or even you can write also kilogram meter s minus 1. It is the SI unit of momentum. If mass is given in gram, you need to convert into kilogram. If speed is given in centimeter per seconds or in kilometer per hour, then you need to convert that value into meter per seconds to make the unit kilogram meter per seconds as per SI system of rules. Next, children. This is something actually I have not done with the momentum topic. I will come back on this topic. You know, there are so many things to discuss on momentum, but I want to go as per the information given in this book. So next topic, that is uh, force and momentum. That the relation between force and momentum. This is also important topic. Children. Important topic. How force is related with the momentum. And now, children, I want to do some calculation. I want to do calculation, and I want to move to the, I want to share white paper, a whiteboard, children. And then the topic is now a relation between force and momentum. Okay, force, let me write here, force and momentum. How force is linked with momentum. So that we are going to find force, you can know, we can write F, and for momentum we can write P. So how F and P are related to each other, we are going to find out that relation. And I want to start this relation by writing a very famous equation from the Newton's second law. And all of you are aware that the Newton's second law is F equal to product of mass into acceleration, that the resultant force is given by mass of the object, moving object, and accelerations produced in the object. And which is equal to, what is acceleration? Acceleration, you know, change in velocity, v minus u by divided by t. If you consider that object started from the rest, you can put u equal to 0. Otherwise, this F is equal to m into v divided by t. What is this mv? What is this mv? That is momentum. So basically, then it means you can write force is equal to, actually when we write mv minus u, means further you can write, if you open the bracket, you can write mv minus mu divided by t. What is this here, this upper in the numerator side? This is called a change in momentum. Change in momentum. Change in momentum divided by time. So change, again children, whenever we say the change in momentum, change is represented by final momentum minus initial momentum. Remember children, careful, initial momentum, you can write it here, divided by time. So final momentum minus initial momentum, that divided by t, that is give us the value of force. So this is the relation between force and momentum, that force is equal to the time rate of change of momentum. So when you, it means when you apply a force, actually what is the meaning of this equation here? When you apply a force on any object, momentum of the object will change in a given unit of time. And this happens when we apply a force, object change its velocity. Object change its velocity, and when, if there is a change in velocity, so it means there will be change in momentum. So force is equal to change in momentum divided by time. Again, children, and you can find the same expression here. It is also given in your book. Here you can find that F equal to ma, that force is equal to change in momentum divided by time. And both are the part of the Newton's second law. F is equal to m into a, and then you can find F is equal to change in momentum divided by time. I will suggest you children, please note it down this equation, that force, that the resultant force is given by change in momentum divided by time. And this expression also, please remember how I have found it, that F is equal to change in momentum divided by time. Now, children, please pay attention to our next topic, that is impulse. Here, that you can see this heading, impulse. For impulse, I can use a letter I, impulse with the letter I, and this impulse is given by, what is this impulse? This is equal to force multiplied by time. It is the product of force multiplied by time. And basically the meaning of impulse is, what is impulse actually? Impulse means it is when a force act on any object for a very, very short interval of time. That is called impulse, impulsive forces. Listen again, children. When a force act on any object, means the impact of force on any object, it remains for a very, very short duration of time. Means here this t is, you can say this time is very, very low, very, very less time. When a force act on any object for a very short interval of time, then it means we are dealing with the impulsive forces. Examples. What examples we can find in our nature, that where we can find a force act on an object for a very short duration of time? I want to give you some examples, children. First examples. When a batsman, batsman hit a ball with a bat. When a batsman hit a ball with a bat, so the impact, the ball collide with the bat, and the impact, batsman exert some force on the ball, and the contact of the ball with the bat, or the contact of bat with the ball, it is for a very, very short duration of time. So that is impulse is there, impulsive force is there. I is equal to force multiplied by time. The second examples, those students who like to play badminton, impact of racket on the shuttle, it's a very short duration of time. And the impact of force, you can see that the shuttle move from one side to another side. Another example, when we hit a nail with a hammer, when we strike a nail with a hammer, so the force applied by the person on the nail is for a very, very short duration of time. So these are the few examples, children. There are many examples. The collisions between anywhere in the world, when the two cars, when accident occurs, the cars collide, vehicles collide, objects collide with each other for a very, very short duration of time. So if I can write that the impulse force multiplied by time, then here they have written here, this is equal to change in momentum. Now you have to go to the result from the Newton's second law, that the relation between force and change in momentum. If I write here change in momentum divided by, this is not mom, this is momentum, children. Okay, so divided by time. And so if you cross multiply, what will you get? F times t equal to change in momentum. Change in momentum. So basically, change in momentum is equal to force multiplied by t. And what is F into t? That is impulse. So all are interconnected, all they are related to each other, as impulse is equal to force multiplied by time, and change in momentum change in momentum is equal to F multiplied by t. Remember children, don't forget that we are talking about change in momentum. And what is this change in momentum? Let me write here. This change in momentum is, I can write this result in another way. F into t, F multiplied by t is equal to, I know this is change in momentum. So change in momentum means final momentum minus initial momentum. That is the meaning of. So product of F and time t is equal to final momentum minus initial momentum, or F into t is equal to, what is final momentum? By taking the mass m, velocity v, initial momentum mass by taking the same mass, and the initial velocity u. So mv minus mu, which is equal to further by taking m common, v minus u. So all these things you have to keep it into your mind, children, how momentum derivation, momentum equations you have to apply while solving questions, numerical problems, children. So please note it down, all these equations which I have written here on the screen. F into t, basically that F into t is equal to change in momentum. And if you know the meaning of change in momentum, that the change in momentum is final minus initial momentum. Now, let us do some questions, children, to understand the meaning of this topic. And I want to take one numerical here, which is given here in this book. Read this statement carefully, children. You have a model car whose mass is there. It is traveling in a straight line. If its velocity increases from where? Its velocity increases from 3 meter per second to 9 meter per second. So it means that u is initial velocity is 3 and final velocity is 9 meter per second. There is a change in velocity in a time period of 4 seconds. What is the resultant force on it? Now there are different ways to do this question, children. First, we will use the same our old concept, that F equal to m into acceleration, children. So you can write the mass is given in the question 2 kilogram. What is the acceleration? Acceleration, you know, v minus u by t. That is the equation of acceleration. So 2 into v, what is v? Final velocity 9, minus u, what is the u? Initial 3, divided by the time duration is given 4. And if you do this calculation here, 2 2s are 4, 9 minus 3 is 6, 6 divided by 2, 6 divided by 2 is coming to be 3. And what is this 3? 3 we have calculated 4, so its unit should be Newton. So here we got the answer Newton. So I want to do this topic, the same question here in terms of momentum, because we are have studied the topic momentum. I want to do this question with the help of the momentum equation. And let me write here, what is the momentum equation? F into t is equal to, maybe I have to find the force, so let me write here, change in momentum divided by time. You know this equation, how the force is linked with the momentum? F equal to change in momentum divided by time. Change in momentum, again children, this is what? Mv minus mu divided by t. We have this equation of momentum, that is the change in momentum, final momentum minus initial momentum. What is mass? 2. Velocity, be careful children, remember this v for the final velocity I'm taking here, 9 minus m, again mass is 2. What is u? It is given in the statement, 3. Time is given, there is a change in this speed within a time period of 4 seconds, divided by 4. 18 minus 6 divided by 4. What is this? 18 minus 6. 18 minus 6 is 12. 12 divided by 4. Then again you will get the same answer, that the resultant force acting on the model car when the speed changes from 3 meter to 9 meter per second in a time period of 4 seconds, then the resultant force will act on the object is 3 Newton. So children, that's for the day. I don't want to take so many things today.